Welcome back to Science Modernizers. Welcome back in this video. Today we are going to see a paper 1 physics, and this is actually the Adamawa mock. That's the Adamawa Teachers Association mock, so it is the Adamawa mock, in other words the Nord mock. So we are going to see this paper 1, and in this video we are going to answer the first section. And the first section encounters or entails the first 35 questions. So if you are not yet subscribed to our channel, do well to subscribe to our channel for more of such videos. So let's fill the information. So today is the 23rd of May 2024, and the candidate's name, you write their name, CIMO 413, candidate number SM 413, center number XYZW. So we are going in for the advanced level. Okay, so we are going to begin with the questions. So we'll be very brief. I'll be very brief. We have 35 questions to answer, so we have to maximize time. Physics paper 1 is one of the papers which many people shy away from. So in this video we are really going to see how to analyze our options keenly in order for us to come out with good results. Okay, question number 1 reads, so the instructions as well says each of the 35 questions or incomplete statements in this section is followed by 4 suggested answers. Select the best answer in each case. So one answer should at least be correct, one answer. Now, number 1, a particle is executing simple harmonic motion with period t. At time t equals 0, it is at its position of equilibrium. The kinetic energy time graph of the particle will look like. So the first thing we have to know is how to calculate the kinetic energy. So the kinetic energy is normally given by a half mv squared. The formula booklet has assisted in some formulas, but the displacement wave is given by a sine omega t. So if you get the velocity, which is y prime, it's going to be a omega, that's omega a cos omega t. So that's the velocity. So if I replace in ke will simply be a half m omega square a square cos square omega t. Now the graph of cos squared omega t will definitely be only above. So the graph of the cosine function is something like this. So now that it is squared, it means the negative part will disappear. Now what do we see? Let me rearrange this in a good way. So it means the kinetic energy will be a half times m omega squared a squared. Now I'm going to write this cos squared as we know from the trigonometric identities that cos 2t is equal to 1 2 cos squared t minus 1. So it means that my cos squared t will be equal to cos 2t plus 1 divided by 2. So I'm going to use that notion here. So here we are going to have that this will be equal to cos what do we have? Cos 2t is not really necessary for us to split it like that, so let's just leave it like this. Cos squared omega t is not necessary. Now at this stage I just wanted to explain something using that particular notion, but I just realized it is not really necessary. Now with this we have that the graphs of c and d can never be the correct options because it is already starting from the origin, whereas the cosine function begins from a maximum point of 1. Now at this stage, what do we have? We can now calculate these respective values. Let us see how we can get their respective phases to know where we are going to get a maximum and where we are going to have our minimums. Now at this stage, what we can do is we can take, for example, at t equal to 0, you see that this is 1, so there we have something maximum. So when t now is equal to, let's take for t is equal to, let's say t on 4. Yes, as we are seeing there, or let's try to take t on 2 and verify what t on 2 is going to look like. Let's start with t on 4 before we go to t on 2. At small t equal to t on 4, what do we have? we are going to have cos squared omega times t divided by 4. But remember, what's omega? Omega is 2 pi divided by the period. So if I replace, it means I will have cos squared into 2 pi divided by the period times t on 4. The t's we cancel, this goes here 1, this goes here 2. So we have cos 90. And what does cos 90 give? So that's cos pi on 2, all of that squared. And what does cos pi on 2 give actually? So cos 0 normally is 1, so cos 90 is 0. So this will give us 0 right there. So it means pi on 4, at pi on 4 we are going to be at 0. So you see that at instantly the best graph that we describe all those characteristics will be B. Now we go to number 2. They say heat cannot by itself flow from a body at a lower temperature to a body at a higher temperature. The statement is of which of the following? A. First law of thermodynamics. B. Conservation of mass. C. Conservation of energy. D. Second law of thermodynamics. The correct option is the first law of thermodynamics, where we see that delta Q is equal to delta U plus delta W. Is that okay? Okay, so the correct option is A. Question number 3. Which of the following statements is false? 1. A rheostat can be used as a potential divider. This is true, since we always see rheostats at the level of when we study the potential divider, so a rheostat is there. The Kirchhoff's second law represents the energy conservation. True. And also note that the Kirchhoff's current law, that's the first law, it represents the law of conservation of charges. Okay, 3 says the Wheatstone's bridge is most sensitive when all the 4 resistances are of the same order of magnitude. That's true, and especially when it is at balance. So this statement is true, so it means the wrong one will be D. So D will be our correct option. But let's read it. In a balanced Wheatstone's bridge, if the cell and the galvanometer are exchanged, the null point is disturbed. Never. It's not true, because the null point is always obtained when the reading of the galvanometer is 0, so there is balance. Now this is a Wheatstone's bridge. A Wheatstone's bridge is this sort of a circuit, something like this. Something like this. Okay, then here there is a link. Somewhere here we now have our galvanometer. Then you now connect your thing. So that's actually the Wheatstone's bridge. So it's found in 2015 paper 2, and there is a video on that on our channel. So the correct option for this is option D. So that's the one that is wrong, option D. Question number 4. Question number 4. Some energy levels of molecules are shown in the figure below. The ratio of the wavelengths lambda 1 into lambda 2 is okay. So let's remove all this thing. Okay. Okay, so we are going to begin by, we have the transitions. We have 2 transitions. I'll call this transition 1 and I'll call this transition 2. Transition 1 has, okay, let me just respect norms. I will call the big transition 1, and I will call the second transition 2. Now this has a wavelength lambda 2 and this is lambda 1. Now what do we see? We are going to calculate the variation of the energy. Let me say delta E1, and it is going to be negative E minus negative 1/3 E. Now but remember that the variation in that energy delta E1 will be equal to Hc divided by lambda. Now lambda 1 for us, we're on 2, sorry, I'm dealing with 2 here, so that will be 2, it will be lambda 2. So it means that that will be 1/3 E minus E is equal to Hc on lambda 2. So this implies that I have E on 3 is equal to Hc on lambda 2. So we'll call that equation 1. So similarly, we do the variation in E1, and the variation of 1 will be equal to, we'll have negative E minus negative 2E. So this will imply that E will be equal to HC divided by lambda 1. We call that equation 2. Now we are looking for the ratio of lambda 1 divided by lambda 2. So if I take equation 1 divided by equation 2, we have HC, or E on 3 divided by that E in equation 2 will be equal to HC on lambda 2 divided by HC on lambda 1. Now I will change this to a multiplication sign and invert their position. So it will be lambda 1 divided by HC. So the HC's will cancel, E and E will cancel. So we clearly see that the ratio will be equal to of lambda 1 divided by lambda 2 will simply be 1/3. So what's the correct option? B. Now question number 5. Okay, so let's go to number 5. Number 5 reads, River Vina at one section is flowing from east to west at a speed of 5 meters per minute. A man on the south bank of the river, capable of swimming at 10 meters per minute in still water, wants to swim across the river in the shortest time. He should swim in the direction A, due north, B, 30 degrees east of north, C, 30 degrees west of north, and D, 60 degrees east of north. So let's represent the scenario. So we have this is our east, this is our west. So the river is flowing as such. So let's say these are the banks of the river. It's flowing as such, and the man is somewhere here at the south, and he wants to cross the river. Now he wants to cross the river. Now definitely it is clear that if he wants to cross, the shortest distance will simply be this vertical line. That's it, very clear. So it means the correct option there will just be A, because since that's theoretically, that's actually what we can see. But under real life, the currents are like this, they are going this way, and it means that as he will be swimming, normally he should swim in such a way that he will be deviated by a certain angle, which we can call theta. You see, so that's how he's going to be traveling. So that will be the direction of his velocity. So but since we are looking for the shortest of the distance, it means it's simply going to be due north, and that will give us A. Now how then can we see that? Now we can also do that mathematically from here. Now we see that we have two components here. We have the horizontal component and the vertical component of the speed. So the vertical component of the speed, which is our interest, will be equal to V times the cosine of theta. And now we are looking for the shortest distance, so it also implies the shortest time possible. Now from velocity is equal to the distance traveled divided by the time. Let's use S all over t. It means that my t will be equal to velocity divided by S, but no, sorry, S all over velocity. Now this means S will be equal to, since it's going vertically, so we are going to take the component V cos theta. But remember, we are looking for the minimal distance. So minimal distance will definitely imply minimal time. So now when will time be very minimum? Time will be minimum if the value of the cosine of theta is maximum, and the maximum value of cos theta is 1. So it means we are going to have S on V, and if cos theta is equal to 1, it means theta is equal to 0 degrees. So if you come here, 0 degrees with respect to this point is simply vertically upwards. So it means that the correct answer will simply be A, due north. Now number 6. A body starts from rest at time t equal to 0. The acceleration time graph is shown in the figure below. The maximum velocity attained by the body will be, so maximum velocity will simply be the area under the acceleration time graph. And what are we seeing? We observe a right angle triangle, so the maximum velocity v will simply be a half base times the height. So that will be a half times 10 times 11. So that will be 5 times 11, which gives 55 meters per second. So B is the correct option. Now number 7. The velocity displacement graph of a particle moving along a straight line is shown below. So that's what we have. The most suitable acceleration displacement graph will be, okay, so we are going to use some interpolations. That is, we are going to extrapolate a given equation from our graph. Then from there, we now see how to get an equation for the acceleration. Now remember, this is my y-intercept, that is the x-intercept. Now if this is my origin, this displacement or distance will be x and this distance will be v naught. Now it means the gradient of that slope will simply be negative v naught divided by x0. Now if I write this in the form y is equal to mx plus c, what is our y? Our y is v, so we have v will be equal to negative v naught divided by x naught, all of that times x plus c, and our y-intercept is v0. Why is there a negative sign? Because our line is sloping downwards, so the gradient is negative. That's why you see that negative sign there. Now with this, what are we looking for? The acceleration time graph. So that's the equation of the velocity time graph. But remember, acceleration in terms of velocity by the chain rule is given by v dv on dx. So if you know that acceleration is dv divided by dt, you can simply multiply this by dx on dx. Now you see that dx on dt is speed, so that's the v there times dv on dx that's left. So that's from the chain rule. Okay, so from here we can get that our acceleration will be equal to what's our v? Our v is given by negative v naught all over x0 times x plus v0, then all of that times dv on dx. So we differentiate this with respect to x. Derivative of v naught, since v naught is a constant, is 0, and when we differentiate negative v naught on x naught, x will simply give us negative v naught all over x0. Now if we multiply, we have v0 all over x0, all of that square, times x plus minus v0 square divided by x0. So this is an equation of a straight line in the form y is equal to mx minus c. So it means that our intercept will cut by the negative y-axis, so the correct graph will be A. Number 8. Okay, clean this. Okay, question number 8. Which of the following statement is not true for a particle moving in a circle with constant angular speed? A. The acceleration vector points to the center of the circle. That's true. We talk of the centripetal acceleration, so that's a correct statement. B. The acceleration vector is tangent to the circle. Acting towards the center, tangent. Wrong. So this is not correct. So option B is wrong. So that's the correct answer, B. Yes, says the velocity is tangent to the circle. Always true. Velocity is always tangent to the circle, and the velocity and acceleration vectors are perpendicular to each other. Correct. So the wrong one there is B. Number 9. A particle of mass 100 kg is thrown vertically upwards with a speed of 5 meters per second. The work done by the force of gravity during the time the particle goes up is, we can use equations of motion or we use the work energy theorem. So what does it mean? It means that W, or the work done by external forces, will simply be equal to mg, so a half mv squared. So the change in kinetic energy, a half mv squared. So what do we have? This work done will be provided by m times, since it's moving upwards, will be negative g times h, and this will be equal to a half. The mass is 0.1. 100 grams is 0.1 times the speed, which is 5, all of that squared. Now this is our energy, so this will be negative E, so I can just call that work done to be negative W. Now if I bring the negative the other way, it means I will have W to be equal to negative half into 0.1 into 25. Now 25 divided by 2 is 12.5 times 0.1. It will be negative 1.25 joules. So the correct option here is B. Question number 10. Question number 10. Number 10 reads, the figure below shows the position time xt graph of a one-dimensional motion of a body of mass 0.4 kg. The magnitude of each impulse is, so here we have what's impulse? Impulse I is equal to ft, which is equal to the change in momentum m into v minus u. So in other words, it's going to be p final minus p initial. Now let's do that. So here we are looking for the magnitude of the impulse. The first thing we have to do is to get our velocity. So we have a displacement time graph, so the velocity will simply be the gradient under this. And what will be the gradient? So I'll take initial velocity vi, that's from this point right up to the peak. Now it's going to be the gradient, and the change in y is 2 minus this 0, which is 2. So I'm going to have 2 divided by the variation of time, 2 minus 0, which is 2. So yeah, so that'll be 2 on 2. We are going to have 1 meter per second. So we have v final, we are going now down, so the slope changes, so it will simply be negative 2 divided by 2, that will be negative 1 meters per second. Okay, so what's going to be the impulse? So impulse initially will be, so let's calculate I initial, or let me just say initial momentum was pi. Pi will simply be mvi, and what's our mass? 0.4. So it's going to be 0.4 times 1, which is 0.4 kilogram meters per second. What's p final? Still going to be 0.4 times negative 1, which is going to be negative 0.4 kilogram meters per second. Now what's j or I? Impulse is equal to pf minus pi. So that will be negative 0.4 minus 0.4. So that will be equal to negative 0.8 newton seconds. But we are looking for the magnitude, so we take the magnitude. The magnitude of negative 0.8 will be 0.8 newton seconds. Correct option B. Number 11. Okay, question number 11. A particle executes simple harmonic motion with a frequency f. The frequency with which the kinetic energy oscillates is f on 2, f, 2f, 4f. So what's kinetic energy? We saw in the first question that kinetic energy is a half m omega squared a squared cos squared omega t, and we saw there that we have a half m omega squared a squared into, here we have cos 2 omega t plus 1 divided by 2. So I've simply converted cos squared omega t into an identity in terms of cos 2t, as my earlier set from the trigonometric identities. So we know that cos 2t is equal to 2 cos squared t minus 1. So if you make cos squared t, you have cos 2t plus 1 divided by 2. So that's exactly what I've done. Now what do we say about this thing? Now for the normal oscillator, what we have is if y is equal to a sine omega t, this means it is oscillating with f. Now how will the ke behave? The ke, we have here we have cos 2 omega. So what do we realize? Our new omega 1, our omega 1, let's say it's omega, but our omega 2 is 2 omega. So it means omega 2 will simply be equal to 2 times omega 1. But remember, omega is directly proportional to frequency, since omega is equal to 2 pi f. So if omega doubles, it means the frequency also doubles. So it means the correct answer is C. Question number 12. Question number 12 with number 12 says a linear harmonic oscillator of force constant 2 times 10 to the power 6 Newton per meter and amplitude 0.01 has a total mechanical energy of 160 joules. Its A, maximum PE is 100, B, maximum KE is 100, maximum PE is 160, maximum potential energy is 0. So what do we have? Since we have a spring, let's calculate the maximum kinetic energy. KE max will be equal to a half times KE square. So this will be equal to a half, the spring constant is 2 times 10 to the power 6 times the amplitude square, that's 10 to the minus 2, all of that square. So this will be equal to 2 and 2 we cancel, so I have 10 to the minus 6, so 10 to the 6 times 10 to the minus 4. So this will be equal to 100 joules. So that's KE max. So KE max is 100. Okay, so we have B is correct. So option B is correct. Now let's go to the next. in a PN diode, in a PN junction diode not connected to any circuit. So we have a PN. So let's say here I have my P and I have my N. Remember, here we mostly have holes and they are positively charged, and here we have electrons. Okay, so what are they saying? They're saying that when it is not connected, A, the potential is the same everywhere. B, the p-type side is at higher potential than the n-type side. C, there is an electric field at the junction directed from the n-type side to the p-type side. And D, there is an electric field from the junction directed from the p-type side to the n-type side. So since here we are mostly going to observe positive charges which are supposed to be diffusing onto the p-type side, it simply means that the direction of the E field will leave from the positive terminal to the negative side. So definitely the correct option here will be C. Question number 14. Which of the following statements is not true? A, the resistance of intrinsic semiconductors decreases with increase in temperature. So we know that for semiconductors, when temperatures increases, their resistance decreases. So that's a correct statement. Doping pure silicon with trivalent impurities gives p-type. Correct. The majority charge carriers in n-type semiconductors are holes. Wrong. The electrons. Whereas the next will be correct. So the PN junction can act as a semiconductor diode. True. So the correct option here will be C, which is wrong. So it is the n-type. The majority charge carriers in the n-type are electrons, not holes. Number 15. Which of the following represents a gamma decay? In a gamma decay, the mass number and the protonic number doesn't change. So the only equation which gives that is C. So correct option is C. Question number 16. Question number 16. A beam of electrons is used in a Young's double slit experiment. The slit width is d. When the velocity of the electrons is increased, then A, no interference is observed, B, the fringe width increases, C, the fringe width decreases, and D, the fringe width remains the same. Okay, so what are we doing? We are varying velocity. Now what do we know? The fringe separation is given by lambda d divided by A. D is the slit to screen distance. Lambda is the wavelength of our radiation. A is the slit separation and Y is the fringe separation. Now also, how then can we do this? So we are dealing with a sort of waves known as de Broglie's waves. So we have to calculate. Let me replace lambda by de Broglie's wavelength. So de Broglie's wavelength is calculated as h on p, where p is the momentum, so that's h divided by mv. So if we replace, y will be equal to lambda, which will now be hd divided by mva. So we see that there is an inverse relationship between y and v. So it means as v will increase, y will decrease. So the fringe separation or the fringe width will decrease. We go now to the next. Question number 12. 17. In a given process on an iodine gas, dW is equal to 0 and dQ is negative. So if dW is 0 and dQ is negative, dW is 0 already means constant volume. So it means B is wrong. Now the next, the temperature will decrease. That's the correct answer since dQ is 0. So it's less than 0. So the correct option will be A. Next. 18. 2 kg of ice at negative 20 degrees Celsius is mixed with 5 kg of water at 20 degrees Celsius in an insulated vessel having a negligible heat capacity. Calculate the final mass of water remaining in the container. It is given that the specific heat of water and ice are 4.1 kilojoules per kilogram per degrees and 0.21, while the latent heat of fusion of ice is equal to 334.9 kilojoules. Okay, so what do we have? We have a certain container it means there is water and we bring ice inside. The ice will surely dissolve and either some will be lost in the form of vapor or probably what we can say is maybe all the ice might not dissolve. So there are several possibilities we can picture this particular problem. Now what then is going to happen? Now what do we see? We have a 5 kilogram mass, that's for water. So let's start by writing down the energy equation that will rule this. So one can say the heat loss by the water at 20 degrees is equal to the heat gain by ice. Now since the ice will melt, it means there's going to be a transition of states. So this will give M water, C water, delta theta of water. It will be equal to the heat gain by ice. Since heat has a certain absorbing capacities, we have Mi, C of ice, delta theta of ice, plus a certain Hertz heat. So what do we have? M times L F. Since there is a change of state from solid to liquid, so at that time temperatures are constant, so it means there is a hidden heat, so we take it into consideration. Now what we are going to do is we are going to calculate the mass of ice that will dissolve. So Mi will simply be equal to Mw Cw delta theta W, all of this divided by Ci delta theta I plus Lf. So let's do numerical application. Mass of water is 5, specific capacity 4.19 times the variation in temperature 20 divided by Ci 0.21, variation in temperature 20 plus 334.9. So I didn't do any convention since all their units are the same. So let's punch that and get what it gives and see what it gives. 5 times 4.19 times 20 will be divided by 4.2 plus 334.9. So it gives us about 1.24 kilogram. So this is about 1.24 kilogram. So it means that the total mass M total will be M water plus M of ice that has dissolved. So that will be 5 plus 1.24, which is equal to 6.24 kilograms. Now we have 7642. Well, we are going to take the one that is closer, and the only closest answer there is B, which is 6 kilogram. Question number 19. Okay, question number 19. In which of the following processes convection does not take place primarily? Now let's follow it keenly. Now the first, sea and land breeze. So convection is a sort of heat transfer which occurs in fluids, so that's air and liquids. So sea and land breeze, convection occurs. Boiling water, convection occurs. Heating air, convection occurs. But warming of a glass bulb, convection does not occur there primarily. So the correct answer is D. Question number 20. The temperature of an ideal gas increased from 120 Kelvin to 480 Kelvin. If at 120 Kelvin the root mean square velocity of the gas molecules is V, at 480 Kelvin it becomes, now the molecular kinetic energy is equal to 3 divided by 2 kT, where K is the Boltzmann constant. But that molecular kinetic energy is equal to a half mc squared bar, and that will be equal to 3 on 2 kT. So the 2's will cancel out. It means that c squared bar will be equal to 3 kT divided by m. Now I will now call our initial condition. So I will call one C1 squared bar, that will be equal to 3K into 120. Temperature is 120 divided by m. Since it's the same gas, so 3K on m is a constant. Then we also have C2 squared bar will be equal to 3K into 480 all of that divided by m. Now if I take c2 squared bar divided by c1 squared bar, what will happen is these 3k's on m's we cancel, so I will have 480 divided by 120. So 48 on 12 is 4, but we are looking for the root mean square. So our root mean square is c2 squared bar will be equal to 4c1 squared bar. So taking square root, it means c2 bar will be equal to square root of 4 is 2 and square root of c1 is c1 bar. So it means it will double. So the correct option is B. Okay. Now let's follow. Now we are on the next, that is 21. A wire fixed at the upper end stretches by a length L. By applying a force F, the work done in stretching is, what's work done? Elastic potential energy. So that work done will be given by a half times the stress times strain per unit volume times the volume. So what do we have? That will be a half. The stress is the force per unit area. The strain per unit volume will be we have the extension. Strain is extension divided by original length, so I'll call the original length capital L, and I'll call this extension L. Then that will be times, so the volume will be our area times capital L, the original length. So L and L we cancel, A and A we cancel, so we'll be left with FL on 2. Correct option D, FL on 2. Now let's go to question number 22. If two soap bubbles of different radii are connected together by a tube, so something like this, two soap radii, so what will definitely happen? If you have done this when you were still a child, and this is a bubble, this is a bubble and this is another bubble, you will realize that when you connect them with a tube, what happens here is this absorbs all of this, so this volume will shrink whereas this volume will increase. So let's see, they say air flows from the smaller bubble to the bigger bubble. Correct answer A. Number 23, we have question number 23. We have, which of the following is incorrect regarding the first law of thermodynamics? A, it is a statement of the principles of conservation of energy. It is a restatement of the principle of the conservation of energy. That's a correct statement. B, it is not applicable to any cyclic process. That's true. It is not applicable to all cyclic process. C says it introduces the concept of entropy. That's wrong. Entropy is the second law of thermodynamics, and it is the degree of disorder in a given system. So that is wrong. So the correct option here, they say which of them is not correct, so it's C. C is not correct. Question number 24. A ray of light incident at a glass water interface at an angle of I and emerges finally parallel to the surface of water, then the value of mu g will be, so mu g will be the refractive index of glass. So the ray is traveling as such and it goes up. Now we are going to study it as such. Now this is what is happening at this level. I'm going to assume that I'm going to start with the part above. So when we talk of an incident angle, the incident angle with respect to air, you will clearly see that it is 90 degrees. So if you start from this interface, what do we realize? Or we can also start from this interface. Anywhere that you decide to begin, there is no problem. So what we have here is, here we have the angle of incidence here is 90 degrees. So applying Snell's law between these two interfaces, the relative refractive index mu of 1 to mu 1 2 will simply be equal to the ratio of sine I divided by sine R. Now the mu12 is the refractive index of water divided by the refractive index of air. So the refractive index of air is 1, so we have mu water will be equal to sine I, which is 90 degrees, divided by sine R. So this means that sine R will be equal to 1 all over mu water. The mu water is 4/3, so it means sine R will be equal to 3/4. So we can call this 1. Now if we use now the other interface, sine I divided by sine R will be equal to, what do we have? Sine I divided by sine R will simply be equal to, we have the angle of incidence and the angle of refraction. So we have that sine I on sine R will simply be equal to, since it's our incident angle measured with respect to the normal I, it will be the relative refractive index. So that's that of glass divided that of water, divided by that of glass. Now it means that of glass will be equal to, what do we have? We have that of glass will be equal to mu water times sine R divided by sine I. Okay, so there was mu water. Mu water is equal to 4/3 and sine R is 3/4. So we are going to have mu glass to be 1 divided by sine I. So the correct option will be option B, 1 on sine I. Next question. Okay, question number 25. If G is the acceleration due to gravity on the Earth's surface, the gain in potential energy of an object of mass m released from the surface of the Earth to a height equal to the radius r of the Earth is A, this, B, this, C, that, D, that. So we have the Earth. Now the object is somewhere here and it is raised again to another height, let's say r, and the distance from here to here again is r, so the total height will be 2r. So we are going to calculate the variation in the potential energy. So what's Pe? The gravitational potential energy is given by negative Gmm divided by r. So I'm going to call this to be Pe initial. Now Pe final will be negative Gmm divided by 2r. Now if we take final minus initial, so the variation in the Pe will be final, which is negative Gmm all over 2r minus Gmm all over r. So if you simplify, it's going to give us Gmm all over 2r. But what do we know? We know that the acceleration due to gravity is Gm all over r squared. So this means our Gm will be equal to gr squared. So if we replace, our delta Pe will be equal to gr squared times m divided by 2r. So one of these we cancel, so we'll be left with mgr divided by 2. So what will be the correct option? A. Question number 26. In plotting stress versus strain curves for two materials P and Q, a student by mistake puts strain on the y-axis and stress on the x-axis as shown in the figure. Then the correct statement is, now when we observe the two materials, we see that before one starts undergoing deformation, it takes a higher amount of stress in order for it to undergo deformation. So what does it imply? And this amount of deformation can also be in accordance with what we call ductility. So if, for example, you have aluminium and an iron surface, and you hit aluminium with, say, a very hard material, so the amount in which it might deform itself is what we call the ductility. So it is a given resistance before it breaks and changes its shape. So we are going to call it, we can clearly see from here that P, or the material P, is more ductile than the material Q. So the correct option here is B. Number 27. The same thing. this question repeated itself. So we saw it already above. Question number 28. Okay. Question number 28. A small block of mass 0.1 kg lies on a fixed inclined plane PQ, which makes an angle theta with a horizontal. A horizontal force of 1 Newton acts on the block through the center of mass as shown in the figure. The block remains stationary. A. Theta is equal to 45 if the plane is smooth. B. Theta is equal to 45 if the frictional force is 0.1 acts on the block towards P. C. Theta is less than 45 degrees and the frictional force acts towards Q. And D. Theta is greater than 45 degrees and the frictional force acts towards Q. Okay, so let's analyze the problem. We have a sort of triangle like this. That's our runway. Here we have our mass. Here we have a horizontal force of 1 Newton. So I will call this the same angle here is theta. Okay, so we are going to resolve. I have the weight mg. You have mg sine theta. If I extrapolate this is a right angle. So this component of the 1 Newton force will be 1 cos theta. And in that same direction, we are going to have the frictional force. Now at equilibrium, here we have the reaction. At equilibrium, we have mg sine theta minus 1 cos theta minus fr is equal to 0. Now m is 0.1. I will assume g to be 10 in order to avoid some punchings. Now this means we have mg. So what we have is g is 10 times 0.1. This will give me sine theta minus cos theta minus fr is equal to 0. Now if we assume critical conditions where friction is equal to 0, if our plane is smooth, it means if we take that plane is smooth, it means our frictional force will be equal to 0, and that would imply that sine theta minus cos theta will be equal to 0. And so this means sine theta will be equal to the cosine of theta. And this is true if only if theta is equal to 45 degrees, because clearly we see that this angle is an acute angle, so theta should be 45 degrees. So we see here that option A is making sense at critical conditions. Now, is it going to be the best option? Let's verify the others. Now, what if it stops to be frictionless? So it means it is rough. Now if it is rough, it means our frictional force will come back into play, but we already know the minimal angle of inclination that we need to have, and that is 45 degrees. And so if it is no longer frictionless, what do we have? It means that sine theta will be equal to cos theta plus the frictional force Fr. Now you clearly see that if this is true, and that sine theta equal to cos theta is already 45, then if we add a given quantity which is in such a way that the sum of the cosine of theta plus the Fr will always be less than or equal to 1, then one can deduce that the angle theta will always be greater than 45 degrees. And if it is greater than 45 degrees with our friction force in play, in which direction is the friction? So if we are moving downwards as seen, it means the frictional force will be moving towards Q. So one of the best options here to consider will be option D. If theta is greater than 45 degrees and the friction force acts on the block towards Q, so that will be the best of the options, so that if we are dealing with a case where it is perfectly smooth, we simply take the critical point, theta equal to 45 degrees. 29. The dimension of the quantities in one of the following pairs are the same. Identify the pairs. A. Torque and work. B. Linear momentum and work. C. Energy and Young's modulus. D. Angular velocity and linear velocity. So let's begin with the units. Torque is the rotational moment, so it's Newton meter. Work done, Newton meter, so the correct option is A. The others are wrong. Linear momentum is kilogram meters per second square, and this is Newton meter, so it's wrong. Energy, Newton meter. Young's modulus, stress on strain, so he has the units pascals. Angular velocity is in rads per second, and linear velocity is in meters per second, so the correct option here is A. Number 30. A certain galvanometer has a resistance of 100 ohm and requires a 1 milliampere full-scale deflection. To make this into a voltmeter reading of 1 volt scale, connect a resistance of. Now since we want to convert it into a voltmeter, it means we have to connect a shunt resistance of at least a shunt resistance which is going to be connected in series to our galvanometer. So if you say we have a source, for example, and I have my shunt, I'll call that RS, and here let's say I have my G, something like this, and current is flowing. Yes, we want to use it as a voltmeter, and a certain current flows. That's my full scale deflection current IG. Now the PD across the terminals V will be equal to IG into the resistance of the shunt plus the resistance of my galvanometer. So this galvanometer, we have a resistance which you can call RG. Now you see from there we are looking for R of the shunt, so the resistance of the shunt will be equal to V divided by IG minus the resistance of the galvanometer. Now what is V? Our V is 1 volt, so 1 volt divided by 1 milliampere, 1 times 10 to the minus 3 minus the resistance of the galvanometer, which is 100. So this is 1000 minus 100, so it gives 900, connected in what series? Correct option B. Number 31. Number 31. A total resistance of 3 ohm is to be produced by combining an unknown resistor R with a 12 ohm resistor. What is the value of R and how is it to be connected to the 12 ohm resistor? What do you realize? What's the total resistance? 3 ohm. And what's the resistance of one resistor? It's 12 ohms. So what do you realize? It has dropped. So if the resistance drops, it means definitely they're connected in parallel. So let the unknown resistance be a certain R. So it means the total resistance will simply be R1 times R divided by R1 plus R, since they're connected in parallel, because we clearly see that the total resistance is smaller than the resistor of one resistance. This means that R total will be equal to 12R divided by 12 plus R, but our R total is 3. So if you multiply 12 times 3, 12 plus R times 3 will be 36 plus 3R. This will be equal to 12R. So this means we have 9R will be equal to 36, and if you divide by 9, it means R will be equal to 4 ohms and connected in parallel. So correct answer A. Question number 32. In constructing a thermometer, it is necessary to use a substance that A. expands with rising temperature, B. expands linearly with rising temperature, C. will not freeze or boil, D. undergoes some changes when heated or cooled. So the correct option is option D. Undergoes some changes when heated or cooled. Question number 33. Figure 4 shows two lap bars X and Y of same length 50 centimeters and same cross-sectional area with a common junction. The ends of X and Y are respectively 100 degrees Celsius and 0 degrees Celsius. The thermal conductivities are respectively in the ratio Kx is to Ky equal to 2 is to 1. Which of the graphs A to D is correct? So let's calculate the interfacial temperature and verify it from our graph. So here we have this. Okay, we have an interface. Now you have X, you have Y. This side is at 100 degrees Celsius. This side is at 0 degrees Celsius. Now the interface, the length of one is 50, the length of the other is 50. Now at this interface, we are going to call it the temperature theta. Now the heat flux dq on dt will simply be equal to negative Ka times d theta on dx, where dx is the length. Now this means we have, for the first one, let's say for x, we have dq x on dt will be equal to negative kx times the area times the variation of the temperature, which is inner minus outer. So that will be theta minus 100 degrees. All of this divided by dx, and our dx is 50 centimeters. Now likewise for y, dqy on dt will be equal to negative ky a times outer temperatures minus inner. So I have 0 minus theta, that will be negative theta. All of this divided by dx. Now if the heat, the variation of the heat with respect to time is the same, so it will mean if we equate the two equations, so here we'll have negative kxa into theta minus 100 divided by dx. This will be equal to negative kya into negative theta, all of that all over dx. So we see that the dx we cancel, a's we cancel. Now but remember, and the negative, these negative signs we cancel. Remember, kx is to ky is equal to 2:1. It's equal to 2:1. So this means kx all over ky is equal to 2:1, from where kx will be equal to 2ky. So I can replace it there. So it means that kx will now become 2ky into theta minus 100. So this should be equal to negative ky times theta. So ky will cancel. So this means I will have 2 theta minus 200 is equal to negative theta. So from here we have 3 theta is equal to 200. So we have that theta will be equal to 200 divided by 3, which is the interfacial. Now what's 200 divided by 3? That will be 66.66666, which is approximately 67 degrees. So you see the only graph here which has that particular thing is D. So the correct option will be option D. Question number 34. In a Young's double slit experiment, the slit separation is doubled. This results in increase in fringe intensity, no. Decrease in fringe intensity, doubling fringe separation, halving. So we have y is equal to lambda d divided by e. So what has happened? The slit separation is doubled. So if this doubles, this becomes, you see that y definitely becomes half of, or y1 becomes half of y. So it is halved. So the correct option is D. And question number 35, finally, how does the Doppler effect of frequency of a moving sound source towards a stationary observer? How does the Doppler effect affect the frequency of a moving sound source towards a stationary observer? So the observer is here, O, and the sound is moving towards him, so definitely frequency increases, A. So we are going to end the video here. Thank you very much for watching. Do not forget to like, share and subscribe. See you in the next video.